My screen?
Yes, we do.
Okay, so let me introduce myself. My name is Igor Golovko, and I am studying Khmelnytsky National University in Ukraine. So today I want to present obfuscation techniques, how we can actually improve it using machine learning module. Let's describe three items, why we need it, actually. So the purpose, actually, the goal. The main goal of the research is to examine the efficiency of AI-driven obfuscation system for a high-level programming languages, which produce intermediate language. It's like .NET or Java. After first level of application build. So yeah, after build, we have not execution code, just intermediate language. And after that, JIT compiler, actually just in time compiler will create execution code for us. Okay, focusing on enhancement of software security through intelligent and dynamic obfuscation strategy. This study aims to ascertain whether AI can improve the resistance of application based on high-level programming languages against reverse engineering, comparing with traditional obfuscation methods. Research methodology. The study used a group, pre-test and post-test, designed to evaluate the efficiency of AI-driven obfuscation techniques, compiled files based on high-level programming language. And the scientific novelty of the study is to, of the study is the innovative approach of obfuscation process through the integration of artificial intelligence, making it a significant advancement over traditional static method in, for example, static methods like machine learning for dynamic obfuscation. This is employing machine learning algorithm to analyze and adaptively apply obfuscation strategy based on the code's unique characteristic, enhancing the intelligence of the obfuscation process, resistance against advanced the compilation, introducing metric to evaluate the strengths of obfuscation code against modern the compilation tool, improving resistance to reverse engineering, fuzzy logic in decision making, improving fuzzy logic to handle uncertainties in decision making about obfuscation, and quantitative measures of effectiveness. So actually, this we will measure cyclomatic complexity actually, and see how programs with low cyclomatic complexity are easy to understand and less actually more risky to modify. Okay. So obfuscation concept. The simplified compilation flow, which obfuscation involves several stages that protect the source code while maintaining its functionality. Here's a breakdown. So actually, this is like block schema. First of all, we have source code. This is initial program is written high-level programming language. Compiler, which will transform our language into the intermediate language code. And obfuscation. This is actually after compilation, we can apply obfuscation for ill code. By the way, obfuscation can be at least two types. So we can obfuscate actually the source code, but the problems that if we obfuscate source code, it will study the syntax only for this language. And if we use ill code, actually we can obfuscate the code based on different high-level programming language. The process modified the code to make it more complex and difficult to reverse engineer while still allowing it to function correctly. For example, some tools, one of the metric we will use, this is function, how would say, that program functional correctly after obfuscation. So yeah, and JIT compiler will create now for us execution code runtime. The main components. So actually, we create obfuscation system, and the system contains the main component of the obfuscation system. It contains like input module, the module that's responsible for receiving and the plain code that needs to be obfuscated. It acts as an entry point of the system, ensuring that the code is properly formatted and prepared to subsequent obfuscation process. Data storage. This is a central repository. For this thing, I use a simple MS SQL Server, but actually it is quite possible to use NoSQL data storage. Actually, so it's we can easily switch our model in the system according to our needs. So input code before obfuscation. It includes synthetic and semantic analysis to identify critical section of the code that require obfuscation. Additionally, it's highlight potential vulnerability that could be targeted by reverse engineering, ensuring that this area receive focused annotation during the obfuscation process. Quality verification model. This model ensures that the obfuscation code retain its original functionality and meets the desired level of complexity. So actually, we can tell what complexity, what performance we want to see after our obfuscation process. And reporting model is just a final component of the system that will user can it will generate detailed reports, and a user can, for example, look at the reports. Okay, obfuscation process. Sorry, how it work. So the interaction of these components is essential to the seamless operation of the obfuscation process. The flow begins with input module, where the plain code is fed into the system. This code then passed to processing module, which perform initial analysis and prepare the code for obfuscation. The analyzed code is forwarded to the obfuscation module using AI, where it undergoes a series of transformation based on the selected obfuscation strategy. So this process, the obfuscation rule library and the adaptive learning model work together to ensure that the most effective and up-to-date techniques are applied. Once the obfuscation is complete, the transformed code is sent to quality verification model. Here, the code actually we just test whether this complexity and a different kind of matrix is appropriate for us, like increased complexity and reverse engineering. The result of this test, along with the obfuscated code, are stored in the data storage for future reference, and finally reporting model. Yeah, so it's generate reports, and also we can add integration API, for example, for a third-party application if needed. And the system design ensures that all components works in unison to produce highly secure and resilient code. So the main components of the main obfuscation methods. By the way, these methods can be increased. At the moment, it's like a beginning of my research, and in future research, these methods, of course, we can increase. So at the moment, I use name obfuscation, so it's just replacing the name variables, name methods, classes with meaningless labels to prevent understanding the purpose of the code. The second is a control flow of obfuscation, changes so what does it mean? Change the execution path of the program without changing the behavior, making the logic difficult to trace and understand. In this flow, we also can merge the flow, for example, and it's called mixing flows, and it also will improve our complexity. A script encryption. So if we have some script, for example, if we use some license that hard-coded in our library, and we need to, of course, this will be a crucial part of our library, and we need to protect this license very good. So this encrypts the strings to use the software which are only decrypted at runtime. So actually, when a user tries to decompile our code, actually, he will not see anything useful. And dummy code insertions add irrelevant piece of code that not affected the functionality of the application to confuse anyone trying to redesign the code. And instruction pattern transformation that changes the way of instructions that algorithms are structured with the changing their functionality. So in future, as I said, the set of applications can be increased since the experiment is only initial state, so it's like beginning of more global study. Okay, so methodology. The study adopts a structured approach to access the efficiency of artificial intelligence in extending obfuscation techniques within application. The study adopts a structured approach to assess the efficiency of artifact intelligence in increased obfuscation technique efficiency within application. Initially, the research involved calculating baseline metrics. So actually, we calculate metric before obfuscation. We calculate our performance, schematic complexity, and another metrics. Baseline for a substantial data set to compile in their non-obfuscated state to establish a reference point. Subsequent to this, the metric recalculated for the same files after they have been obfuscated using traditional methods, providing the comparative layer of large and improvements after offered by conventional methods. And finally, these files undergo a further round of obfuscation using advanced AI models. Metrics are calculated once more to access the resilience and efficiency of AI enhancement obfuscation strategy against the reverse engineering. This comprehensive approach underscores a traditional form of manual rule-based obfuscation method to sophisticated automated systems that leverage machine learning, intermediate language code, machine learning technologies to dynamically improve software security. To design an AI-based obfuscation model for ill code, we need to focus on parsing, analyzing, and obfuscating ill code. First of all, we will need to collect data and prepare it for data analysis. We can use, for example, such tool like Monosail, reflection metadata from Microsoft, or other tools that can help us to parse and analyze ill code. After that, we, for different chunks of code, we can select different obfuscation strategies. And next step will be generate a obfuscation model based on AI. For this purpose, we choose one of the recurrent neural network on short-term memory using TensorFlow.net for ill code obfuscation. So, and results of the experiment. So we can see resistance of analysis. Control group, this is actually with traditional methods. We have unsuccessful reverse engineering up to 82%, and with AI up to 97. And yeah, so the higher percentages of unsuccessful reverse engineering attempts, the more effective the obfuscation, of course. And yeah, this next metric that I use, this is functionality integrity. So actually, after that's we just check whether our program works correctly after obfuscation process. And yeah, so as you can see, at the moment, it's quite equal. So yeah, we have 2.5% loss in functionality for experiment group, but in general, it's quite equal. And another result is pattern complexity that I said earlier. 47% for control group for standard obfuscation method, and 89% of undetected patterns for AI. And cyclomatic complexity, as you can see with AI, it increases well, and the experimental group experience up to 55% increases in cyclomatic complexity compared to 28% in a control group, that tell us that actually complexity of our application increased, and that's one of our goals in research. And conclusions, the result of this experiment demonstrates the enhanced capabilities of AI-driven obfuscation technique over traditional methods. As the experimental group showed a significant improvement in resistance to reverse engineering and marked increase in the code complexity while maintaining acceptable levels of performance and functionality. These findings validate the use of AI in obfuscation, providing a more robust and adaptive approach to secure software and transit analysis. The AI-driven approach demonstrates a substantial improvement in the software's resistance to reverse engineering, achieving 97% failure rate for reverse engineering attempts in experiment group compared to 82 in control group. This stark contrast underscores the effectiveness of AI in dynamically selected and applying obfuscation strategies that are tailored to the unique characteristic of the code, thereby making it far more difficult for attackers to analyze and decompile the protected software. Yeah, thank you.
Thank you, Igor. Dear colleagues, any questions? Okay, Igor, the question is to you, what is your further work? What will be the next level
Yeah,
of your
so
research?
the further work will be enhance I want to enhance adaptive model, because at the moment I have not a big amount of rules that we can analyze after AI model obfuscated the code. So what I'm talking about, let me quality verification model. So this is quality verification model. We analyze this matrix and try to understand whether this quality of security is appropriate for us. But at the moment, I have not a lot of rules for analyzing. So my future research, this is update quality verification model to create it a more mature, like that. And as I said, increase the metric. So I increase also obfuscation methods, because it is much more methods. But at the moment, I study this recurrent neural network based on these 5 obfuscation methods. And I also want to increase it, and want to increase also metrics. So I want to add something like memory consumption and metrics. So it will allows us to set up a different variety, actually, of parameters, variety of criteria that we want to use in our obfuscation system. For example, if we not very important memory consumption, but we very important in performance and cyclomatic complexity, that will system will analyze it and try to select obfuscation method especially for this criteria. So
okay, thank you for your answer. Okay.
Thank